Welcome. We will now review two methods for connecting a VPC to external entities. These external entities include the Internet, external clients, and endpoints, and other AWS services. First, we will review NAT gateways, and then learn about VPC peering connections. This chart shows the options for connecting a VPC on the AWS cloud to other VPCs, external endpoints, and AWS services. This table lists common VPC connectivity scenarios. It also identifies the recommended AWS service or networking component to use to implement a corresponding solution. The solutions are divided into the following categories: EC2 instance connectivity, Amazon VPC to Amazon VPC, or network to Amazon VPC. Some of the solutions are also divided into subcategories based on whether they use VPN connectivity or VPC endpoints. For more information on Amazon VPC connectivity options, search for it in the AWS online documentation. We will explore these solutions in more detail in this module. Consider this example configuration. Imagine that you have an instance with a standalone database that runs in a private subnet. You want to apply a software patch to the database. However, the private subnet prevents you from accessing the internet to download the patch. You cannot put the instance in a public subnet because you do not want internet clients to connect to it. However, you need a way to connect from the instance to the internet. How can you do this? You can use a network address translation, or NAT device. A NAT device can allow an instance in a private subnet to connect to the internet or other AWS services. It can also prevent the internet from initiating connections with the instance. A NAT device forwards traffic from the instance in the private subnet to the internet or other AWS services. It then sends the response back to the instance. When the request goes to the internet, the source IP address is replaced with the NAT device's address. When the response goes to the instance, the NAT device translates the address back to the instance's private IP address. AWS offers two kinds of NAT devices: a NAT gateway and a NAT instance. We recommend NAT gateways because they provide better availability and bandwidth compared to NAT instances. The NAT gateway service is a managed service from AWS that does not require manual administration. For more information about using NAT in a VPC, search for VPC NAT in the AWS online documentation. You create a NAT gateway in a specific availability zone. When you create the NAT gateway, it includes redundancy within that availability zone. You provide the NAT gateway with an elastic IP address, which is a static IPv4 address. The NAT gateway supports the following protocols: Transmission Control Protocol, User Datagram Protocol, and Internet Control Message Protocol. You must complete two steps to create a NAT gateway. First, you specify the public subnet where you want to create it, and select the allocation ID of an elastic IP address to associate with it. Secondly, you update the route tables for the private subnets to point internet traffic to the NAT gateway. This enables instances in those subnets to communicate with the internet. For more information about NAT gateways, search for it in the AWS online documentation. This diagram illustrates the architecture of a VPC with a NAT gateway. The main route table sends internet traffic from the instances in the private subnet to the NAT gateway. A NAT gateway sends the traffic to the internet gateway by using the NAT gateway's elastic IP address as the source IP address. As a best practice for better availability, you should use multiple availability zones and host a NAT gateway in each availability zone. VPCs are isolated network sections in the AWS cloud. If you must connect two VPCs to exchange traffic or data, you can create a VPC peering connection. A VPC peering connection is a network connection between two VPCs that enables you to route traffic between them by using private IP addresses. The VPCs can be in the same region, in different regions, or even different AWS accounts. The data exchange traverses privately on the AWS backbone, and no gateways are required for peering to work. The connection is controlled by the route tables, which reference the peering connection as a target for routes. This results in a connection with no single point of failure for communication and no bandwidth bottleneck. The diagram here shows an example of using VPC peering to allow other VPCs to access resources that you have in one of your VPCs. The connection allows resources from account 1 to communicate with the resources in account 2 by using the IP address range of the account 2 VPC. Conversely, resources from account 2 can communicate with the resources in account 1 by using the IP address range of the account 1 VPC. As a result, the resources in both VPCs can communicate with each other as if they were on the same network. You can also use VPC peering to facilitate data transfer. For example, if you have more than one AWS account, you can peer the VPCs across those accounts to create a file sharing network. You can create a VPC peering connection by using the AWS Management Console. VPC peering involves establishing a two-way connection that must be initialized and accepted by both parties. In addition, the owners of both VPCs must establish routes that allow traffic to be sent between the networks. The two networks must not have overlapping address spaces. For more information about VPC peering, search in AWS's online documentation. Here are the steps for establishing a VPC peering connection. First, the owner of the requester VPC sends a request to the owner of the acceptor VPC to create a VPC peering connection. The acceptor VPC owner accepts the VPC peering connection, which activates the connection. Then the owner of each VPC adds a route to one or more of their VPC route tables. This route points to the IP address range of the other VPC, known as the peer VPC. This route enables the flow of traffic between the VPCs by using private IP addresses. If necessary, the VPC owners can update the security group rules that are associated with instances in each VPC. If both VPCs are in the same region, you can reference a common security group as the source or destination of the security group rules. The VPC owners can also enable DNS hostname resolution for the VPC connection. This is required in the following situation. The instances on either side of the VPC peering connection address each other by using a public DNS hostname. The instances also want the hostname to resolve to the private IP addresses of the instance instead of the public IP address. The default behavior is to the public IP address, not the private IP address. Here is a review of the AWS CLI command to create a VPC peering connection. If the command succeeds, it returns metadata about the new connection. You must have the VPC ID flag for both sides of the peering connection. Here are two examples of an AWS CloudFormation script entry to create a VPC peering connection. The script on the left is in JSON, while the one on the right is in YAML. A VPC peering connection goes through various stages. The connection process starts when the request is initiated. The diagram illustrates the states that a connection goes through during a normal creation process. They consist of these following states. The first state is initiating request. In that case, a request for a VPC peering connection has been initiated. The second state is pending acceptance. The VPC peering connection request is awaiting acceptance from the owner of the acceptor VPC. If no action is taken on the request, it expires after 7 days. The next state is provisioning. The VPC peering connection request has been accepted and will soon be in the active state. The final state is active. The VPC peering connection is now active. Traffic can flow between the VPCs, provided that your security groups and route tables allow the flow of traffic. For more information about VPC peering, search for VPC peering basics in the AWS online documentation. The following restrictions are enforced on VPC peering. There can be no overlapping private IP address ranges. For example, a VPC with 10.2.0.0/16 private IP address space cannot peer to a VPC with a private IP address space of 10.2.2.0/24. There can be no transitive peering. If VPC A is peered to VPC B and VPC B is peered to VPC C, resources in A have no direct route to resources in C. This situation is also true in the reverse direction from C to A. There can be no transitive edge routing through AWS Direct Connect. If A and B are peered, and A is also connected to your data center through Direct Connect, your data center cannot directly contact resources in B. There's also no transitive internet gateway access. If A and B are peered, B cannot access the internet in the gateway through A. B must define its own route to the internet. There can be no NAT routing between VPCs. A cannot route traffic through the NAT server in B. You cannot resolve IP addresses. If you are in A and you do a DNS lookup of a private address that is in B, it will not resolve. There can be no cross-referencing of security groups across regions. You cannot reference the security group of a peer VPC that's in a different region. Instead, use the CIDR block of the peer VPC in the source or destination field of that security group rule. The diagram shows an example of one VPC that has appeared to two different VPCs. This example illustrates some of these restrictions, specifically the transitivity limitation. The diagram has two VPC peering connections. A is peered with both B and C. B and C are not peered. You cannot use A as a transit point for peering between B and C. If you want to enable the routing of traffic between B and C, you must create a unique VPC peering connection between these two VPCs. You should also be aware of AWS Transit Gateway. With AWS Transit Gateway, you can connect your VPCs and your on-premises networks to a single gateway. To learn more about AWS Transit Gateway, search for AWS Transit Gateway on the AWS homepage. The AWS site-to-site VPN option creates an IPsec VPN connection between remote customer networks and their VPC over the internet. The resulting connection is secured by using the IPsec protocol. A site-to-site VPN connection consists of the following components. The first component is the Virtual Private Gateway, or VPN gateway. This is the VPN concentrator on the Amazon side of the connection. You create a virtual private gateway and attach it to the VPC where you want to create the VPN connection. Internally, each virtual private gateway has two tunnels, with each tunnel using a unique public IP address. It is important to configure both tunnels for redundancy. When one tunnel becomes unavailable, such as when it is down for maintenance, network traffic is automatically routed to the other available tunnel of the VPN connection. The second component is the customer gateway. This is a physical device or software application on the data center side of the VPN connection. It must have a routable public static IP address. The properties of the customer gateway are captured in a customer gateway resource that you create in AWS. These properties include the gateway's public static IP address and the type of routing it supports, which is static or dynamic. Thanks for watching. We'll see you in the next video. Welcome. We will now review how to secure and troubleshoot networks on AWS. You should secure your virtual network at several different levels. The most broadly scoped level of security is at the level of the route table. Having a private subnet with no direct path to the internet is one of the best ways to protect your internal computing resources against unauthorized access. The second level of security is Network Access Control Lists, or NACLs. With NACLs, you can define the default security behavior of your subnets. The VPC, or subnet layer security, is typically controlled by the network security team. Next, you can use security groups to control behavior at the level of the instance or network interface. Finally, you might choose to use some form of third-party host-based detection software that monitors individual EC2 instances for specific threats or issues. Some of these threats and security issues include malware intrusion, known operating system vulnerabilities, and security auditing. Now you will review some of these layers in more detail. Use security groups to restrict traffic in and out of the associated network interfaces. Some important things to note with security groups are that a VPC has a default security group that allows all outbound traffic, but denies all inbound traffic. When you launch an instance in a VPC and do not specify a security group for it, the instance is automatically assigned to the default security group. Rules are defined in two separate inbound and outbound tables. You can specify allow rules, but not deny rules. All rules are evaluated before traffic is allowed. All outbound traffic in response to an inbound request is permitted. Typically, you will configure security groups with the help of the application development team because they understand the protocols and port numbers their applications use. This example shows the inbound and outbound rules for the mom-and-pop cafe security group. The security group allows inbound traffic only on port 80 for HTTP, port 22 for SSH, and port 3306 for MySQL. It also allows all outbound traffic. NACLs are associated with a subnet in a VPC. They define rules that allow or deny inbound and outbound traffic in the subnet. NACLs are stateless. If a type of request traffic is allowed inbound, you must explicitly define an outbound rule for the same type to allow the response traffic. You define rules for inbound and outbound traffic in two separate tables. Each rule is identified with a unique rule number. When the Network Access Control List decides whether to allow traffic, the rules are evaluated in ascending order of the rule number. The special rule number that is represented by an asterisk is evaluated last. It represents a catch-all if no match with a previous rule was found. Inbound and outbound rules are defined by first specifying the type of rule, such as custom TCP, then provide a rule number and define the port range that will be allowed or denied for inbound and outbound traffic. Finally, specify the resource or destination IP address or range that will be allowed or denied for inbound and outbound traffic. After you define the network ACL, you can associate it to one or more subnets in a VPC. A bastion host is a jump point from the public internet to the EC2 instances and other resources in a private subnet. By using a bastion host, you can access private resources publicly through the internet in a way that minimizes the attack surface of your private subnet. Users must have valid keys for both the bastion host and private instances. We strongly recommend that you use different key pairs for the bastion host and for the resources in the private subnet. The keys for the private subnet resources should not be stored on the bastion host. Any attacker who breaks in to your bastion host would then have access to the resources in your private subnet. For Linux instances, most SSH clients support what is known as agent forwarding. This allows your local SSH program, such as PuTTY, to pass your private key from the client through the SSH connection with the bastion host. It will then pass the private key through the SSH connection to your private network resources. For Microsoft Windows instances, you can use the Amazon EC2 console to generate a login password by using the private key. You then use the remote desktop client program to log into the private instance with the generated password. You must configure security groups to allow the Bastion host to access an instance in your private subnet. First, you can configure your Bastion host to allow only connections from your corporate network. This prevents anyone that is outside your organization from accessing the Bastion host. In the example, the Bastion host accepts only requests from SSH clients in the 17.5.0.0/16 address range. Next, you create a rule in the private instance's security group that allows only incoming traffic from instances that belong to the Bastion host's security group. For example, if your Bastion host has a security group named SG192D536A, you can specify that a server in your private subnet will only allow incoming connections from the Bastion host. You can also specify a server by adding a rule to allow SSH connections from instances that are in that security group. You can also restrict incoming connections to the IP address of the Bastion group. However, specifying a security group is more flexible and reusable. If you run Microsoft Windows instances in Amazon EC2, you will probably perform remote administration using Remote Desktop, also known as RDP. You configure the EC2 instance's security group rules to define the source IPs that are allowed to connect to the RDP TCP port 3389. It is best practice to apply the principle of least privilege when you configure your security groups. In this case, least privilege means that you only allow connections to the RDP port from the IP addresses that your administrators use. However, in cases where an administrator could be connecting from anywhere on the internet, it might be difficult to determine which IP addresses to allow. As a result, users might set security groups for RDP access that allow every IP address by using the open configuration 0.0.0.0/0. This fails to enforce the principle of least privilege at the network layer. One solution to this problem is to protect your Windows instances at the network layer. You can do this by setting up our Microsoft Remote Desktop or RD Gateway server as a Bastion host. You can configure the RD Gateway to accept connections via HTTPS through TCP port 443 from every IP address on the internet. You can then proxy the connections to your other Windows instances by using RDP TCP port 3389. Only users who authenticate to your RD Gateway instance are allowed to proceed to the protected Windows instances behind the proxy. For more information about how to configure a Windows Bastion host to use RD Gateway, search for controlling network access to EC2 instances by using a Bastion host in the AWS documentation. Now, you will review some recommended steps for troubleshooting common issues that are related to VPCs. Here are some common things to check when you troubleshoot VPC connectivity issues. This list is not an exhaustive list, but it should provide a good starting point for troubleshooting problems. Now consider some specific types of scenarios. One of the more common issues that Amazon EC2 users face is that they cannot connect to an EC2 instance. Here are most common reasons for this issue. First, verify the instance is running. Also verify that the security group allows connections over the port or ports that you are attempting to connect to. For example, for SSH connections, verify that port 22 is open. For web server connections, verify that port 80, port 443, or both ports are open. Another configuration you can verify is whether the public IP address has changed. If you stop an instance and then later start it, the instance will receive a new public IP address unless an elastic IP address is attached to it. Also, verify that the Internet Gateway and route table settings are correct. Sometimes users try to log in to an EC2 instance by using the wrong username and password. Though many EC2 instances have an EC2 user defined in the operating system, not all instances do. Also, when attempting to connect by using SSH, verify that the correct private key is being used and that the access permissions set on the key are correct. The ping tool is a common network utility that is commonly used to test the reachability of a host on an IP network. It is available as a command line tool in both Windows and Linux. After you have created a NAT gateway or NAT instance, you must update the route table that is associated with the subnet of the private instance. The route table must point internet traffic to the NAT gateway or instance. This configuration enables the private instance to communicate with the internet. You do not need to troubleshoot the NAT instances that are created by AWS when you use the NAT instance, and you do not use the NAT gateway type. This is a special consideration for companies that modify the NAT instances to reflect their own security rules or processes. If you cannot reach resources in a peered network, verify that the peering request was approved. Also, verify that the CIDR block ranges are configured to allow access across the VPCs. For further details about troubleshooting VPC peering, search for VPC peering connectivity in the AWS online documentation. Thanks for watching. We'll see you in the next video. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In summary, you learned about the role of VPCs in cloud networking. You also learned about the networking components inside of a VPC and their purpose. You reviewed the options for VPC connectivity and learned about the layered network defense model inside a VPC. Finally, you learned how to configure a VPC and to troubleshoot common networking issues. Great work! You will now review a sample certification question. Take a minute to review this question. Review this sample scenario and find any keywords that will help you identify the correct answer. Here, the keywords in this scenario are highlighted. Now review the answers. Keeping the keywords in mind, consider the answer options and try to rule them out based on the highlighted keywords. The best solution in this case includes the 3 highlighted answers. Now it's time for you to complete the Module 7 Guided Lab Configure an Amazon Virtual Private Cloud. You will also complete the Module 7 Challenge Lab, Troubleshoot a VPC to support the Mom and Pop Cafe. Thanks for watching. We'll see you in the next video. Welcome. In this module, we will learn about storage and archiving on Amazon Web Services. You will learn about the main storage services that are offered by AWS, and also about data transfer and migration services. In addition, we provide you with a lab where you get hands-on experience with using several of these services. By the end of this module, you should be able to differentiate between AWS data storage options and explain their purpose and benefits. You will be able to create and manage Amazon Elastic Block Store, or AWS EBS, snapshots. You will also be able to store, retrieve, and archive Amazon S3 objects. Finally, you should be able to identify AWS data migration services. Let's get started.